If the volume of a proton were similar to the volume of an electron, how would the densities compare? With the volumes, first of all, the proton is much more massive than the electron. It might be easier to see using this column, which expresses mass in AMUs. So you see it's magnitudes, orders of magnitudes greater the mass of a proton. That's why we say most of the mass of an atom is found in the nucleus, where you find the protons and the electrons. So just logically, if they take up the same amount of space, then the proton is going to be much more dense. We can show this mathematically as well. So density is the ratio of mass over volume. So we say the density of the proton is equal to the mass of the proton over the volume of the proton. And the same thing for the electron. The density is equal to the mass of the electron over the volume of the electron. And rearranging these, you can say the volume of the proton is equal to the mass of the proton over the density of the proton, and you can also say the volume of the electron is equal to the mass of the electron over the density of the electron. All right, so if the volumes are similar, in other words, they're equal to each other, we can set these two expressions equal to each other. In other words, the mass of the proton over the density of the proton is equal to the mass of the electron over the density of the electron. All right, we've already seen in the chart above that the proton is much more massive than the electron. So in order for this expression to hold true, the density must also be much greater than the density of the electron, the proton's density. Right? So you can look at it that way as well.